Hi, this movie is for Learning Target 1-2, some of the measures of the interior and exterior angles of a polygon. To start off this lesson, let's look at what we are going to be learning, which is in your handbook and the Learning Target page. We are going to learn about polygons and quadrilaterals. Polygons are many-sided figures. So in the first lesson, this movie is going to cover the interior angles of a polygon and the exterior angles of a polygon. We're also then going to start looking at specific types of parallelograms. So let's start with polygons. Polygons are a many-sided figure. You can see here on the left that it has straight sides. In the middle, that's not a polygon because of the curve, and then when it doesn't close, we don't have a polygon. Types of polygons could be regular or irregular. Regular means all sides congruent, all angles congruent. They could also be convex or concave, simple or complex. There are more examples. Now, the names of polygons you'll need to know. For example, triangles, 3 sides, quadrilaterals 4, pentagon is 5, hexagon is 6, heptagon is 7, octagon is 8, nonagon is 9, and decagon is 10. The others that you see here, you don't need to memorize. You could if you wanted to, but anything beyond 10, and we'll use n-gon. For example, a 19-gon is going to be just 19-gon is how you'd spell it, and it means a 19-sided figure. This icosagon is a 20-sided figure. We would call that a 20-gon. So what we're going to do now is go to an investigation page. And that investigation page looks like this in your guided notes. Up at the top, the thing that you'll need to know is that a regular polygon has all sides congruent and all angles congruent. The interior angles of a polygon are these inside angles, and an exterior angle are the outside exterior angles. These would be exterior. Knowing that, on down here with our polygons, number of sides, triangle has 3, 4 for a quadrilateral, pentagon 5, hexagon is 6, octagon is 8, decagon is 10, and then a dodecagon is 12. Now, I'm going to start you off with a few of these. Number of triangles. That means how many triangles are formed inside this polygon to find the sum of the interior. So in this case, in a triangle's case, we just have one triangle, so the interior angles is 180 degrees. If we wanted to find the measure of one interior, we would do 180 divided by 3 if it's regular, a regular polygon, and that would give us 60. We see that the exterior angles are always 360. So the sum of the exterior angles of a triangle, if I were to extend the sides, these are the exterior angles, and they would add up to be 360. If I did 360 divided by 3, then that would give me 120. So the sum, or the one exterior angle, is 120. For a quadrilateral, to find the number of triangles, what you do is you take one vertex and draw all the diagonals from that vertex and make sure it's not a side length. So in drawing that diagonal, we get 2 triangles that are formed. If there's 2 triangles formed, each of these 2 triangles adds up to be 180. So I would do 2 times 180 to get the sum of the interior angles. 360. Then I would do 360 divided by 4 to get one interior angle if it's a regular polygon. And that gives me 90. The exterior angles, if I were to extend the sides, those exterior angles would be 360 divided by 4, and I would get 90. Pentagon is done for you. You can see you get 3 triangles. 3 times 180 is 540. 540 divided by 5 is 108. And it's a constant 360 for the sum of the exterior. So if I divide by 5, I get 72. Let me get you started on hexagon. You would take one vertex to get the number of triangles, draw your diagonals, And then you could see just from one vertex, you don't do the other diagonals, but you can see you get 1, 2, 3, 4 triangles. So from there, to get the sum of the interior, you would do 4 times 180, and that's going to give you 720. To get 1, I would take my 720 and divide by how many I have. Hexagon is 6, and that gives me 120. For an exterior angle, the sum is 360, so I would do 360 divided by 6, and that's going to give me 60. Pause the movie, finish this worksheet, press play when you are finished. Okay, now that you finished it, you have all of these values. Let's look at a pattern up here at the top. A pattern is if I have an n-sided figure, n number of sides. How many triangles do you get? Well, what did you notice? 3 to 1, 4 to 2, 5 to 3, 6 to 4. What did we do all the way down? We did n minus 2. We always subtracted 2. The interior angles, we always took that value and then multiplied by 180. So this is going to be n minus 2 times 180. That gives you the sum of the interior angles of any polygon. So this is really important to know. The sum of any polygon, all the interior angles will be n minus 2 times 180. Very important. Star that. To get one interior, all we do is take the sum and divide by how many sides we have, n. That is not so necessary to memorize because it stems from logic. We would take the sum of what we got and divide by how many angles we have. Take the sum, divide by how many angles we have. So it's not necessary to memorize that as a formula. It is important to know that the exterior angles of any polygon are 360. And if it's always 360, to get a regular polygon's one exterior angle, you do 360 divided by n, n being your number of sides. So these are the two patterns that you really need to know. And you'll see in your handbook that on page 16, this concept map, which is what you really need to know in this section, has these two formulas in it. Because given the sum of the interior angles formula, you can find one interior angle. Knowing the sum of the exterior angles, you can find one exterior angle. Okay, now that that is finished, we're going to go to our notes, and we're going to add this first to our notes. Add this formula to page 16 of your handbook. I think it's page 16, but it gives you the sum, adding, of the interior angles of an n-gon. Pause the movie, add that, and then press play when you're finished. On this one, what is the sum of the interior angles of a 17-gon? What we do is we do the sum of the interior angles I know to be n minus 2 times 180. So this is going to be 17 minus 2 times 180. So I get 15 times 180, and that is going to give me 2,700. Now that is the sum of the interior angles of this 17-sided figure. If I wanted to find one, I'm going to add that. One interior angle, if it was a regular 17-gon, I would do 2,700 divided by 17, which is 158.82. So each one individual angle inside this 17-gon is 158.82. The sum is 2,700 degrees. The sum being all of them added together. For the next part, the sum of the interior angles is 1980. How can you find one? if that's your sum, and we know that the formula we use is n minus 2 times 180, we solve this for n. And the first thing you do is divide by 180. And we're using simple algebra to get 13. Oops. 11, add 2, gives you 13. Alright. This one, we know equilateral and equiangular. Equilateral means all sides congruent. Equiangular, all angles congruent. But a regular polygon means all sides and all angles congruent. This corollary of the polygon angle sum theorem is not necessary to write in the handbook because it stems from logic. You basically are taking the sum of all the angles and dividing by the number of angles. And because it's logical, we don't need to add it. Let's look at this one. Find the measure of angle G in this polygon. G is up here. First, we need to know what the sum of all the angles will be in this shape. It's a four-sided figure, so the sum is going to be n minus 2 times 180. So it's going to be 4 minus 2 times 180, 360. So we know that all of these will add up to be 360. So we get that these give us 258. This is 360 equals plus angle G, and we subtract and we get, so G is 102. Now you can see the variation to this. These could be algebraic expressions, but as long as you know how to get the sum of the interior angles, you're going to be able to know how to set up your equation. Here, we're adding the polygon exterior angle sum theorem. You can see the exterior angles listed up here, examples of each polygon. They don't even need to be regular polygons. But the exterior angles is always going to be 360. Add that to page 16 of your handbook. Here we have a regular octagon. Regular meaning all sides congruent, octagon meaning an 8-sided figure. We want to find the measure of angle 1. Angle 1 is just one of those 8 angles. Well, we know the sum of the exterior angles is 360. If I divide that by how many angles I have, I'll get what one of them is, which it's 45. What is the measure of an exterior angle of a regular nonagon? Knowing it's regular, all exterior angles are going to be congruent. Nonagon is 9 sides. So the sum of the exterior angles is going to be 360. To get 1, I divide by 9. And I'm left with 40. And that's the end of this movie.